So I'm going to be talking about this thing called Istio. Kind of first thing I want to point out that that's a capital I, not an L. When I first kind of looked at this, I was like, why is this thing called Istio? What's going on? But I guess I can't really understand fonts. I don't know. I guess same thing happened with IoT. I was like, why are people talking about lot? What the hell is, what is this? So anyway, right, so this is a bit about me here. So my name is Luke, or Lucas, it doesn't really matter, Holmquist. I'm not sure if you can tell by my accent, I am from the United States. If you were expecting somebody with a Swedish accent, sorry. They tell me my name is pretty Swedish. I am a senior software engineer at Red Hat, which you may have heard of us. We've been in the news lately. So there I work on, trying to make the developer experience on OpenShift for Node devs great. Hopefully, that's we're doing that job. I gotta get the mouse. Here we go. So on Twitter, I'm Sienna Lucas, so if you want to follow me there, that'd be awesome. I think I'm at 199 followers, so I'll give somebody a high five. They're the 200th follower. All right. According to the quick napkin math that I've done over the past few years, I'm the only one that doesn't drink coffee of the software engineers that I know. So yeah. Also, nobody has ever actually said, Luke, I am your father. Definitely not. Nobody's ever said that to me, ever. I've never heard it before, so I'm not even sure what Star Wars is. Yeah. So, also, I am a huge Fish fan. So if anybody here wants to talk to me about that band and the insanity that happened last week at their Halloween show, please come see me afterwards. I will be happy to talk about that. So anyway, that's me. All right, so just a sort of a quick disclaimer about this talk. So Istio itself is, and the concepts I am going to be talking about are a bit OPS-y, kind of the operations side, and kind of the deeper you go into it, the more OPS-y it becomes. And I mean, if you're into that thing, that's pretty cool. But personally, I'm definitely not an ops person. I'm definitely like a developer. I like creating apps. I don't like worrying about those operation things or those, it's probably why I prefer Mac OS, because it's nice and shiny and they have buttons to click and things work. And yes, I am using Fedora on this laptop, but it's just because the new Macs are just crap and, So, right, and that's not the last tangent I'm going to go on, during the talk, so just be prepared for that. Right, so being not an ops person, researching this kind of made me go out of my comfort zone a little bit, which is good because when you do that, you start to learn things. So you didn't think this talk was going to be a motivational speaking thing either, so. Right, so and since I'm more a developer person and not an ops person, I'm trying not to go down the rabbit hole too much of DevOps, So it's kind of, we've heard of this minimal viable product stuff, but I'm calling this minimal viable rabbit hole. All right. So I guess the acronym for is MVRH maybe, or MVH for minimum viable whole, but I don't know. That doesn't really sound right. So you know what? We're going to do real quick. I'm going to do a Twitter poll, and everybody here can vote on this, and we'll see what it is. Don't worry, I saved it as a draft, so it doesn't take up too much time. Okay. So okay. All right. So okay, cool. Wow, my first live tweet. So anyway, after getting through all that stuff. All right, so with all that stuff out of the way, let's kind of see what we're talking about today. We're going to say, what is Istio? Because, it's in the title of the talk, so we might as well talk about it. What exactly is a service mesh? And these things kind of go together, Istio and service mesh. And then as a developer, why exactly would you need to use this? We'll see a couple use cases that are sort of relevant for us as developers. Also, this is going to be high level, so there's really nothing Node.js specific, and that's sort of one of the goals of Istio. And I'll probably mention this a few times, but one of the goals is definitely being able to take your existing code and not have to modify it and add sort of these bits of functionality on top of it. So I think it allows you to focus on your application code, which I think the buzzword for that is business logic. Maybe in the Java world that's what it is. So if you're writing your applications in Java or Go or Swift, I question why you're at this conference, but that's that's a different topic. But you could essentially write that and then Istio's layer on top, but we'll get into all that stuff later. All right, so let's crack on, as somebody from the UK might say, and get started with this. Yeah. I've gone over these jokes a lot, and I still crack up over them, so yeah. All right, so we're going to start with something familiar. At this point, everybody, I think, knows what microservices are. We've been talking about them for the last couple of years, but just as a refresher, in case anybody doesn't know what they are, they're a small set of services or applications, and they're loosely coupled together, and perhaps they're even totally independent of each other. They fit well in containers, and that's sort of a very simple explanation, but I think everybody knows what they are, so I didn't really feel like I needed to sort of go too deep into that. And of course, Node is great for them because their Node applications are easy sort of to compose, and they make these little small independent things. They have relatively small footprints, and their boot up time is pretty quick. So they're very good, I think, for microservices. But I think we already knew that anyway because everybody's at this conference, right? And I'm sorry, this is the third Zoolander thing in a row, and it's the second we've got to one in a row too. But anyway, so of course we can't talk about microservices without talking about everybody's favorite container orchestrating platform, and that's Kubernetes. So if you're not familiar with Kube, here's just a definition from their official docs that I kind of wrote down here. So Kubernetes is an open source system for managing containerized applications across multiple hosts, providing basic mechanisms for deployment, maintenance, and scaling of applications. And of course, there are a few popular implementations out there, like OpenShift, Azure has one, GKE, which is Google Kubernetes Engine, and there's probably a few more. So Kubernetes is definitely this very popular thing that's kind of the base for a lot of these different sort of platforms as a service things. But with microservices, we all know that they're great, but they also have sort of a lot of complexity to them, and they do have some problems, right? So instead of this one big thing, you're breaking into all these little tiny smaller things, and to manage those, it gets kind of tough, right? Things like doing a Canary deployment, for instance, which is when you want to do a new version of your API instance very slowly and add traffic to it, that gets kind of tough. Or if one service fails, it could take everything down. So we need to handle those kinds of things in code right now, maybe with something like a circuit breaker pattern or something like that. But even finding like the correct spot where the error occurred could be a bit hard. If you have like 10 microservices and then you get an error in one, it could actually be in like the 9th one in the chain or something like that. So that could be a little bit hard, right? So in a way, microservices, I know I've talked about this with my colleagues before, it is a bit like Jenga. And I noticed that there was a Jenga game, like a kind of a bigger one, and the cool hangout area over there. So I don't know, maybe coincidence, I don't know. But actually, right now, at this very moment, not before, not like when I was testing this out, I just realized that they're actually like little mini Death Stars. They're mini Death Stars. Maybe minus the destructive power to destroy a whole planet, or do they? I guess it depends on your application that you're doing. And I did use this picture because it is probably a better representation of what our services actually look like that we're deploying. They're fully operational ones. But anyway. But no matter what analogy that we use and we give these things, the fact that we need to combat these complexities, you usually have to add things to your code, and usually that's not fun. You want to focus on your application code, not the other things. We don't want to get bogged down in all these different sort of operational things that we have to add to our code. We just want to write and do what the application is supposed to do. And that's kind of where Istio and the service mesh concept come into play, right? So if you're keeping score, this is slide 13. This is the first time I've actually mentioned what Istio is, and we're about 10 minutes in. So if you're keeping track, that's what that is. Right. So let's kind of talk about this service mesh thing first, right? So what is it? So service mesh, it's a configurable infrastructure layer for microservices applications. It makes communication between the service instance flexible, reliable, and fast. The mesh provides service discovery, load balancing, encryption, authentication, and authorization, support for circuit breaker patterns, and other capabilities. So a service mesh is really sort of a concept and a way of doing things There actually are a few different open source service meshes that are available. Linkerd is one, Conduit, and then Istio. And Istio, I think, is currently the best known one at the time right now. So, all right, so Istio. So, Istio, so I believe it's Greek for to sail or just sail. I don't really know Greek, but it's what I saw on Google. So let me read you a little bit of what they say on Istio's site that is what Istio is all about. So Istio makes it easy to create a network of deployed services with load balancing, service-to-service authentication, monitoring, and more without any changes in service code. And you'll see me talk about that a lot because it's sort of a theme that you don't have to really change code, which is great. You add Istio support services by deploying a special sidecar proxy throughout your environment that intercepts all network communication between microservices. And then you can configure and manage Istio using its control plane functionality, which I will define in a minute. And those things include kind of automatic load balancing between your traffic. You get better fine-grained control for routing and those adding different rules and those kinds of things. So I kind of use the term control plane here. I hate when people use terms and they just kind of assume people know what they are, because I usually don't know what they are. So let's kind of see what this control plane thing is here. And here's sort of an overly complicated diagram of it. So the Istio Service Mesh, and I'm using now Istio and Service Mesh kind of interchangeably here. So they split it up into a data plane and a control plane. So the data plane is at the top of this little diagram here. And that deals with the actual traffic from one application to another. So any networking stuff regarding the actual service requests, such as routing or forwarding stuff or load balancing, are part of the data plane. And this is where it's also a collection of the intelligent proxies, which is based off Envoy. So Envoy is it's a robust proxy written in C++. I think Lyft was the original creators of that. I didn't write that down, but I think that's true. And those are deployed as sidecars, like I said earlier, for each of the services. And then we have the control plane, which is at the bottom, and that sort of manages and configures the proxies and how they do things. Also in there, there's things like this thing called Mixer and some other things that do other parts of Istio, like collecting telemetry data and enforcing those policies. And I'm sort of being a bit hand-wavy, another Star Wars reference, with the whole pilot, Mixer, and Citadel thing, that's on the bottom, but minimum viable rabbit hole, so we got to stick to that. Right. So yeah, so I mentioned the sidecar, and that's how you would deploy or enable Istio in your deployment, and that little bit of YAML there is kind of how you would do it. It's kind of on the bottom part in that little annotation. You would just add that little bit, and you said it's true. And Istio is, as long as you have Istio obviously set up in your environment, that's how you would enable it, and the sidecar would be injected, and you could just start using things. Right. All right. So Istio has some core features that we could probably just kind of do a quick sort of run through here. Also, some of the definitions of these are just from the official docs, and so if you wanted to go see more, and you don't actually need to tweet say, oh, this sucks because he was just reading the definitions. I'm telling you now, it's going to suck. So you don't have to actually tell me that on Twitter. So, all right. So one of the things is security. So here's a very, very overcomplicated image that I'm just going to put up. You don't have to actually look at it. It's just I need an image for the slide. But Istio provides the underlying secure communication channel and manages authentication, authorization, encryption between the service communications. And everything, and all the services are secure by default, which I think is one of the greatest features. And then you can incrementally sort of enforce policies based on things that you want to do. And there's no application code changes, which I've said probably a bunch of times already. Right. So then one of the other things is observability. This is where you get into tracing and those kinds of things. So Istio's robust tracing, monitoring, and logging gives you deep insight into your service mesh deployment. You get to sort of see the performance impacts that your apps have, and you can kind of follow the path of a particular application from start to finish and see how that all sort of maps out. The default dashboard in Istio is this thing called Kiali, and it allows us to see our services and how they're all connected. I think, yeah, so the red on there means that there was an error or something in that service. So hopefully whoever took that screenshot will get that service fixed. But I don't think it's a real service, so we don't have to worry about that. So that's OK. And the last one is the traffic management feature, which I think is probably going to be the most important one for us today. Right, so Istio has some easy rule configuration and traffic routing, and it lets you control the flow of traffic and API calls between services. It simplifies the configuration of service-level properties like circuit breaking, timeouts, or retries. And it makes it actually pretty easy to set up tasks like if you're doing A/B testing or you're doing Canary rollouts or some stage rollouts with some sort of percentage-based traffic splits. Yeah, so this shows, you have a service and and you want to add something new to it, and that top one is doing 95% of the traffic is going to go to those services, and then 5% of it will go to that bottom one. And then the bottom one does a very similar thing, except it's using user agent for this to figure it out, and then it routes it that way. All right, so we've seen a little bit about Istio, sort of at a high level, what it's wanting to provide for us, as an application developer, what do we really care about here? Probably all of them, actually, to be honest. But we only have 25 minutes here, so we can't really focus on all of them. So what can we take away today, right? So here's a scenario. Let's say Monday morning, right? You go back to work. Your boss calls you into her office, and she asks you, how was NoConf? And I saw there was this talk on Istio, which looked really, really cool. And you're like, yeah, man, it was pretty dope. So, and so you say, I think probably a first step to kind of get our feet wet in this whole thing is probably around this traffic management stuff, and like the routing aspect of it. So, you know what? That's what we're going to take a look at. Right. So as we saw, with the sort of that quick overview of traffic management, it kind of lives. Those features live outside of our application's code. It kind of lives like at a layer above. I guess you could sort of think about it as like a programmable network layer, almost like if you're familiar with service workers. It's sort of similar to that, I guess. Right. So, it's pretty easy to handle failure recovery with timeouts and all this. And I've said all this stuff before, right? And there's kind of a cool thing is you can actually inject faults if you wanted to, and that's for testing failure recovery policies across your services. Or if you just want to be a jerk and make people's stuff fail, you could do that too. Right. Right. So with the routing stuff, so there's a few new Kubernetes objects that we should probably check out because that does the routing stuff, and those are gateways, virtual services, and destination rules. And here's kind of like a high level of sort of how they sort of would interact with each other, just to kind of give you a sort of a picture as we're talking about this in your mind. Right. So we're going to start with gateway. So this is usually located, and if you kind of look at this thing, it's located at the very top in the edge of your mesh. So this is the thing, this is the load balancer, and this is the thing to enable sort of traffic to come into your application and come into your service. If you're familiar with like an ingress from Kubernetes, it acts slightly different. The gateway only controls things like your the ports that you expose, and maybe your TLS or transport layer security. Is that what that means? Configuration. And then what you would use would be the standard route rules, and you would bind those to the gateway. Bind the virtual service that we'll see to a gateway to enable that. So basically, this is, if you want traffic to come in to hit your service, you're going to need a gateway on the outside for that. But doing service-to-service communications with inside the mesh, you actually wouldn't need a gateway. This is just for coming outside. Right. So, and then this is just an example of maybe what a gateway might look like. It's YAML, which I'm told is human readable. I don't know. I'm fluent in JSON, so sometimes this looks a little bit odd. Right. So, and as you can see, that we're not really binding to any host because we're just binding to star here, so it would work for everything. And we're accepting traffic here on port 80. And just HTTP. If you wanted to do HTTPS, you would add just another little section in that server's sort of array there, and you could set up your certificates and that kind of thing. So it just kind of kept it small, just so it would fit it would fit on a slide, and wouldn't get sort of overwhelming with all the stuff that's there. Right. So then, like I said, you need to bind. So for a virtual service, you actually need to bind the gateway to it to work. But a virtual service will define the rules that control how the requests for the services are routed once you get inside the mesh. So like a service could route to different versions of different services. They can be based on like a header or something like that from the traffic. You can associate weights to them. So and we'll see an example of this. About 3 minutes, so we'll see if we can go through this quick. Right, so here's just another example of a virtual service. And this one, it's matching a particular URI that's coming in, and then it will actually rewrite it to just be the root. And then that will route to this made-up service that we created here called Node.js Istio Routing Client, and that's the destination. Right. Yeah. So we'll just keep on here. So the next one is a destination rule. So this actually configures the policies that are applied to a request after the virtual service routing has occurred. And Istio sort of intends that like maybe a service owner would create this. So this is where you would describe like your circuit breaking stuff or maybe your load balancer settings for services and some other things. So then this example here is just what it might look like for just a very simple load balancer for another made-up service. And so in this one, we have two versions of a service. And by default, this will actually just make it to be 50-50 routing between the two services. But if you wanted to slowly, say version 2 is brand new and you want to slowly roll that out, or maybe only have a percentage of traffic to go to that, which is known as, people call this Canary Deployments. This is sort of what it would sort of look like. You would add another virtual service to that, and you could say, here there's the weight properties here, and one of them I'm saying 90% go here, and then 10% of your traffic go to this other thing. And you can take that a step further if you want to match headers or something, or a user agent. Or even if you're good at regular expressions. Personally, I'm terrible at them, but if you are good at regular expressions, you could add those in there as well and kind of make this dynamic, powerful thing. So yeah, here we go. So injecting faults. This is kind of neat. So in this case, what we're doing here is we're adding just a 5-second delay to 10% of the traffic going into that version 1 thing. So if you had some fault testing you wanted to do and you only wanted to do it on a small percentage, this is how you could do it that way. So that's that. And then there's just another fun one where we're actually sending a 400 error to 10% of our traffic coming in. Like I said, if you want to be a jerk about doing stuff, you could do this. But I get there's fault testing. And I feel like when I buy concert tickets online, they might be doing this to me as well. So maybe they're using Istio. I don't know. Right, and I've shown this over 3 sort of virtual services, but you can combine these all into one. I'm not going to do it here just because it would just be too much stuff. But you could do it all in one thing, and and that's kind of where the power starts coming in, where you can get all these rules sort of set up, and you can see, and with no code changes, which is absolutely great. So I'm just going to kind of put a minute left here. So. And then, so if you want to do circuit breaking, it's kind of the same thing. You set up another rule kind of thing. This one is just a very simple one. It's allowing a max of 100 connections if you're coming in through TCP, or 10 connections if you're coming in through through HTTP. And once that if more than that happens, then your circuit sort of breaks. Typical circuit breaker thing, and then it gets sort of ejected from the pool. And this one is a little bit more slightly complex, but it is a bit contrived. This one has this outlier detection property, which will check your service every, at an interval. This one happens to be 1 second. It would obviously be better, more. And for every, it would say 1 consecutive error. If it errors the first time, then it will just eject that from the pool of stuff for 3 minutes in this case. But this is where you do it. But for something like this, you would also want to, I know I've been saying that you don't have to change code, but something like this, you still need to handle the errors in your code. So there's still some error handling. So maybe you might want to combine this in your code with a circuit breaker library, something like a Possum or something, if you're writing Node code. Oh, cool. So yeah, so I kind of just scratched the surface on Istio, kind of went through it kind of quick. Hopefully I didn't go too far down the rabbit hole here. So go vote on the Twitter poll, and I guess it would have been more appropriate to tell you to go vote yesterday because of the U.S. elections, but anyway. Not that we're in the U.S., but right. So here's some links. Obviously I'm going to send you the slides because you can't come up and click the screen. So, but all right, thank you very much, and I'll leave you with my kids' school pictures, and And there you go.